You know, I'm loving this 29 by 9 resolution, and you're wondering why is it so zoomed in. It's because my camera does 1080p, so I had to scale it to fit these wide bounds. Anyways, if you saw the last video, and that's going to be a prerequisite for this one, you saw that we started making Minecraft in Blender. Why? Because, I don't know. I mean, eventually I want to turn it into like a fully functional game and turn it into like a course and everything. But at the moment, this is more so of a proof of concept. So what you're seeing right now, if I'm not too lazy to edit this, which I feel like being, but whatever, I'm going to do it, is where we left off last time. And what I want to add this time is, I don't know if I'm going to do procedural trees. Maybe I will, but we're definitely going to be making trees and spawning them, and hopefully at some point we can actually have interaction. Okay, that's what we're doing. And before we get into that goodness, you know what's coming. This video, look at that bokeh. This video is brought to you by Squarespace, and let me tell you about Squarespace in anticipation for this Minecraft video. So, if you're trying to make a website or you've made a website, you're going to know the pain of coding, of HTML, of CSS, of all this stuff you don't want to mess with because you just want to have a website. Well, that is where Squarespace steps in, okay? They basically got website templates that you just drag and drop elements, and that's kind of the essence of it. Here are 3 features you might want to know about Squarespace. First of all, of course, you have your analytics, which means you have data. Who's going to your website, what country are they from, and a bunch of other stuff. 2, you have the asset library. This is basically a drive in the cloud that keeps all your website files, like images, banners, video, whatever. And then the 3rd feature, which I always say as a feature, but like really it's kind of the whole idea of Squarespace, is, again, you're using templates and you get to drag things around, so no code if you don't want to. Check it out, and when you're ready to take that thing live, you can click my link in the description to save 10% off your first purchase of a website or domain. Okay, here's what is going on. So I'm sure I already showed you footage of this, but I'm quite proud. And last time I ran this, we kind of had issues with doing screen capture while also playing the game. I guess because both are using the GPU extensively. I've changed computers, so maybe that's better. So here's our procedurally generated landscape. I think I want to cut off this, let me do overlay. I think I want to cut off this like bottom section is one thing we'll do. And second of all, I want to add trees. So those are 2 things we're going to do. But, let's check our game using, navigation. I'm using walk navigation. That, boom, has gravity, and apparently it also has sprinting, which I think uses the same controls and also crawling as base Minecraft. I did not know that. We got our jumping. Let me make it a bit taller. At some point, we'll do our like actual game mechanics. There we go. But yeah, that's what we got so far. I know it's flickery. Also, I added a sky, as you can tell, for the lighting. I think it looks super cool. Now, one of our goals is going to be porting this over to Eevee Next because it has like ray tracing in real time. But the flickering is a kind of a artifact of how we calculated our materials in Eevee. But, we might be able to get rid of it. I think it's more so of a math rounding error. Anyways, that's not what we're focused on today. What we're focused on is making trees. Now, by the way, if you're noticing some lens distortion, again, hopefully you saw the other video, this is because of the overlays that I've done in the compositing, which you can also use for game menus and stuff like that. Okay, enough nonsense. I'm going to get rid of our geo. By the way, do you like that? Do you like the camera in like at the top right of this massive screen? I'm a big fan of this workflow of the 21 by 9. It makes screen capture a little different, but you know what? I'm here for it. So what do we have so far? You know what? This camera is a little distracting. I'm going to exit the camera. What do we have so far? We should have a grass block, which is looking jank, but it does work at the geo level because we're using our like attributes for it. So remember, we're basically we're basically using realize instances and then coordinate systems and all that. It works, but now it doesn't work on a per object level, which is fine because I don't want it to anyways. And let's get rid of this. And we have our dirt block. If I want to do trees, we're going to need 2 new kinds of blocks. Specifically, we are going to need a wood block, which isn't as easy as the other ones. We actually have to do some like patterns because it does have some like stripes to it. And also a leaf block that has transparency. So I'm going to start with the wood. And the hard thing about the wood is, again, it has these lines, but also it kind of has like a top like cross section of a tree, which is going to be a bit harder. Either way, let's do our materials. And I need to exit all of this and also exit the camera. In fact, let's hide the camera so I stop doing that. Okay, so this is going to be our wood block. Correspondingly, I want to give it a wood material. And let's change a couple things. So remember, the way this is working is we have generated coordinates. I quantize it. What do I do here? I displace it to basically get some like random values. So again, if I didn't do this, we'd get a different pattern. I run it through a mix and, BSDF. This is fine, but the wood has not just this random thing, it has stripes. So let's talk about how to do that. Stripes, to me, is something, yes, we can do mathematically, but I think it would be much easier to do it with one of the pre-made textures. So you can see we have our wave texture. I believe we can only get it on X or Y, so we're going to have to like do some kind of mixing. But actually, I kind of like this Z component. I wonder if we can rotate it. Let's do investigation. So what I'm trying to do is get vertical stripes on every axis. Of course, I want to bring down the scale. And let's see if I can do a rotation. So what I'm thinking is I'm going to map our coordinates such that, well, we don't want to rotate on the X, we don't want to rotate on the Y, and Z does nothing. Boo, tomato. Well, I guess maybe what we can do is we can use UV coordinates to do this. Otherwise, we're going to have to do a lot of math, which is fine. Although I do want to do our like quantizing step. You know what? Let's try to do it with UV coordinates. So new approach. This object, I believe, does not have default UV coordinates. So we are going to need to unwrap this. Or no, it does have default UV coordinates. That's interesting. So let's see what's going on here. Here's our UV map. I see the issue. UV map is a 2-dimensional kind of operation. So I don't want to use the Z-axis. It doesn't exist. We either want to use X or Y. Okay, so now this boils down to basically modifying our... I mean, that looks pretty good, actually. Modifying our UVs, although this seems to have been a little hack immediately. You know what? Let's just use that. So I'm going to make a certain number of stripes. Let's say that it's 6. And the trick is we're going to send it through our quantizing step. In fact, let me just copy this over. And eventually we can make this a node group. But I think I'm probably going to stop this series on this episode. Because I don't want to make an entire Minecraft game. This is just a proof of concept. So we're basically going to get the same thing with our quantization step. But now we got to kind of... I believe the issue, actually, by the way, is we kind of have this T thing, whereas it kind of expects it to take up the entire UV space. So actually, if we reset our UVs, you're going to see now well, let me get rid of this quantization step. Now we have like very nice identical like orientations and everything like that. And if I was to like take a face, we can control it individually, specifically the rotation. But that's fine. We could also do this trick where for the top and bottom faces, I don't really want them. So I'm going to Well, we could do like different material assignments. If you can't tell, I'm doing this on the fly. So for the top and bottom, I want to assign a second material. So I'm going to call this is a new material. I'm going to call this wood top, assign the material, and now we've kind of separated this. Okay. So again, I want to do my quantization step is the reason why I modified our UVs. So now if I open this up, yeah, it should quantize it more correctly, kind of following this 12 by 12 grid we have, although now we have stripes. And here's a trick to get more visual interest. What I can do is I can add some distortion, which still has stripes, but now it's not as, not as repetitious in some sense, not so perfect. And now when I view it, we kind of have to find a good balance here where it has stripes, but not too much. So you can see how we're getting that bit of extra detail. And speaking of detail, you can kind of play around with this until it looks right to you. But this is how I'm basically going to get stripes without kind of like breaking up the pattern too much, but just adding a bit of something. Okay? And the scale is going to be your number of stripes in some sense, although you have to kind of respect your snapping. So maybe let's bring this up to 5, and our distortion is going to break up the pattern. Okay. So the rest of this is we're basically going to follow a very similar process as before, where we're going to use the mix factor. Oh, wow. It's almost the correct colors immediately, but we're going to kind of tint it a bit yellow. So ideally we put the colors in immediately, but I'm just going to run this through a hue saturation to kind of streamline the process. So what am I looking for? Is it the brightness of it? Yeah, I think it's the brightness of it. So I'm going to make it a bit brighter, but it's still kind of the wrong color. So I want to tint this. It's a little hard to find this perfect kind of color scheme here. There we go. Maybe a bit darker is actually the way to go. But something like this is a good start. Again, we can play with this later to get our correct number of stripes. Actually, something like that doesn't look half bad. And now we have to do a kind of similar process with the top, but now I believe, again, I haven't played Minecraft in a while, but I believe it kind of looks like this cross section where everything outside the square is basically the same material as here, but everything inside the square kind of has the rings of a tree, which is kind of this like radial expansion kind of idea, which is different math. So for the wood top material, I'm actually going to reuse our wood material, but I'm going to do some modifications. So this is actually going to be our wood top. Maybe we'll call it wood top new, so it doesn't have the same name. And I can clean up our, so you can see we're getting rid of one material that's unused, which was the wood top material, and now I can call it what it's supposed to be called. So I want to use a similar process, but instead of a wave texture, I need to somehow get rings. Now what I'm thinking is actually wave texture has this feature, let's call it. Yikes. Let me get rid of the distortion. It has this feature called rings, so you can see maybe how that would be useful. Oh, there we go. That kind of seems correct. Rings are going to make circular waves in some sense, like a ripple. Of course, we kind of need to turn these into squares, but you can see that's kind of a start. And the reason it's looking off is it centers at the coordinate 0, 0, 0, which for generated coordinates is in the corner rather than here. One quick fix for this is we can just kind of hot swap this, but because I want to use the same kind of coordinate system, I guess it doesn't really matter, does it? But I want the player or the user to be able to kind of modify the UVs. So all we need to do is do a bit of a shift by -0.5. So I'm moving it backwards such that this coordinate, which was 0.5, 0.5, 0.5, we subtracted by itself, it becomes 0. So this is where we center it. And now we can kind of do a similar process. So I'm going to run it through our quantization, which it doesn't seem to like too much. And I guess we can talk about why that is. But this should get us kind of close. Perhaps, let's see what this looks like. Yeah. Perhaps we just kind of need to play around with the numbers a little. So that's what I'm going to do. So it seems like if we can kind of get rings, but it's not really looking perfect. And I'm trying to figure out how we can kind of bring this kind of detail back. Right? Because we do have the correct coordinate system. If I was to get rid of this snapping, it should be fine. But clearly we need to do some kind of modification here. So I guess first of all, we need to kind of square it up instead of circling it up, but I'm going to kind of forego that step for now, because I believe when we quantize this like well enough, it shouldn't be an issue. Okay, now we're actually getting something. So it seems to actually be more so the number here, but I want to kind of fix this up. Now, one thing I'm seeing is because we're kind of quantizing it, it's going to be a little off-center because it will either be left or right. So maybe I can cheat this a little by saying it's 13 steps, or maybe kind of like shifting it a little. I don't know if the user is going to notice, honestly. But yeah, there we go. I'm just going to cheat it a little by adding an extra voxel or pixel or whatever you want to call it, and correspondingly shifting it. Am I doing it by 1/13? I don't know what I'm doing it by. I'm just shifting it by a random number, and that seems to work. So actually this isn't too bad, but we can ask ourselves, can we do a bit better? And maybe we can play around with these types. By the way, what this does is it creates different kind of patterns here. So I'm just trying to get as much mileage as we can for free. And maybe adding a bit of distortion will break this up a little. And then I run it through the same kind of material. It seems like now I do want to kind of alter this, where now it's kind of like a brighter wood. So I'm going to do something like this. Maybe make it, I don't know, more desaturated. And I just want to get some more like yellow tones in here. So something like that. And we can kind of play with this, but it seems like it's a bit awkward. I think one thing that could help is kind of like squaring up these waves, which is kind of like a pain because right now we're just using a nice radial function that, you know, grows and it's simple to calculate for. But if we want to square it up, we have to use something called the taxicab metric. What is that? Well, basically, the way this is calculated is I want you to imagine this is the same square. We start at the origin, which is 0, 0, 0, and then we're looking at the radius. So here we're going a little outwards. Here's the radius is 0. Now it's like 0.2. Now it's like 0.4 until we go all the way. And then on this kind of radius, we're mapping a sine wave, right? So you can see we have this set to sine. We can do it in anything. But that's going to make it so as we expand outwards, we're going from black to white to black to white, which is fine. But the radius is kind of like a radial thing, right? It's the same in every direction, whereas I want this to have corners and stuff like that. So basically, instead of the radius, what we need to use is a different metric. It's called the taxicab metric because instead of using kind of like this diagonal radius to get to this point, what I'm going to do is I'm going to say the distance is more so going to the right and going up. So instead of this like hypotenuse, we're kind of saying drive like a taxi in New York City, where you have to go along this grid where you can only move horizontally and vertically. And that should kind of turn it more so into a square. So we can kind of take this wave texture and make it manually. That's the idea, at least. So let's try this. Here we have our basic coordinate system. For now, let's actually just kind of look at our... For now, let me just kind of center this because it doesn't expect there to be 13 pixels. So I'm just going to center this for this version. And now... I don't know why it's doing that. That's kind of strange. But For now, I just want to do a bit of a modification. Again, it's kind of strange that it isn't centered, but we can go back and figure out why. Either way, the taxi cab metric, again, is looking at how much we go along the X plus how much we go along the Y in this case, since we're looking at it from the top-down view. So, in theory, all I should need to do is separate this into its X and Y components, and then just kind of add them. However, I want to say, so if you're going on the y-axis, this is saying don't move anywhere, and now we're getting further on the y-axis, but this is negative. I don't want that. I want to say going up and down is the same thing. We're kind of still going equally far away. So I'm just going to get rid of our negatives by throwing this through an absolute value. So now you can see it's kind of symmetric. And then we want to do some kind of like addition or something like that. We'll figure it out. There might be a cleaner equation for this. But I'm going to take these. I'm going to add them together. And now you can see we kind of get this diamond. Whereas if you were to do a radial function where we kind of calculate the radius, let me just show you what that would look like. So I guess I'm going to use the centered coordinate system, and we're going to calculate the length, which is the same thing as the radius. We kind of get this. Well, the issue is right now we're also using the z-axis. I know I'm kind of getting in the weeds here. But you can see if we kind of project it on the xy plane, we get this radial thing, whereas with our new system, we get something like a diamond, and really the thing we need to check, there we go, as you can see when we kind of do a, sorry that I keep like picking my nose, there's something really itchy in there. I recently trimmed some of my nose hairs because they were coming out. Maybe that was a mistake. But you can see we're kind of getting the square rather than a circle. And to me, that tells me we're getting a taxi cab metric. And remember, what we were doing is we were taking a sine wave along the radius. Now I want to take a sine wave, kind of a weird idea, but I want to take a sine wave along this taxi cab metric. So let's try to do that. I'm going to take not a sine, but a sine wave. And to check that this is working, I'm going to increase the period. And now you see we're getting something like this. So this is actually more so what I'm looking for. And I want it to be a factor of 12, so it kind of works nicely. Additionally, I'm noticing that it's oriented the wrong way. So we could do some fancy math, or really we could just rotate it, right? And there's a node for this instead of calculating something called the rotation matrix. I'm going to use mapping and then rotate it about the z-axis, not by 90 degrees, because that would just kind of do the same thing, right? But by half a right angle, 45. So that's looking much nicer. We can kind of play with this more so. But you can see the idea is whereas before we kind of had this wave texture that was radial, now we have something like this. And then at this point, you probably know the idea. We're going to throw it through our quantization step. And let's see what that gives us. It's definitely something. I may or may not want to rotate it. But now you can see it's quantized. And we throw this through our taxi cab metric. And I guess it, in some sense, undoes the rotation. Couldn't tell you. But now we get... I mean, this almost has its own issue in some sense, because I want these to be, like, perfectly aligned. But you can't get everything, can you? So, before we subtracted by this number, I wonder if swapping this out will center it. Not too much, but we were assuming that we were using 13 pixels. I don't really know. We might have to cheat this a little. It's kind of weird that we're not using like perfect numbers, but whatever. I do not care. So I'm going to move it up on the Y and left on the X until it's kind of looking centered. And we're going to call that good enough. As we bring up our pixelization, we should get something that looks a bit better, but we're kind of sticking by this 12 to 12 or 13 to 13 idea from before. Now, what I'm thinking is, do we have a way to kind of like rotate these? I don't know. it kind of seems like it likes it as is. But let's see if we can kind of alter this, maybe. So this is our taxi cab metric, which is diagonal. So maybe if I... Doesn't like that too much. So I might not know how to do this for now, but let's throw this through another mapping node and see if we can fix it. Okay, that seems to be good. As I rotate this quantization step, it seems like I regain some control. Right? I don't know, because we have our quantization, and then I'm taking this and rotating it. Couldn't tell you, but let's see if we can get something a bit nicer. So I want to rotate by, it seems like, it's kind of weird, right? Like in theory, I want to rotate it by half a right angle, but then we kind of get this thing. So really what we need to do is kind of change our metric here. But now, it's getting quite confusing. So you could play with these numbers. Oh, yeah. You could play with these numbers to get different results. To be honest, I'm not quite sure. I guess here's what it is. We're taking the taxi cab metric this way. So we're kind of using X and Y coordinates, which I guess will inherently give us something like this. But instead, you can see we kind of are offset by 45 degrees. If we were to use these diagonals, right? So instead of the X and the Y axis, rather I want to use these diagonals as an axis, then that would be a bit better. But that's a bit more complicated. Well, let's think about this. This is kind of just straight up the x-axis. This is the y-axis. How would we describe the... Let's kind of do something like this. Well, this is the graph of y, and this might be a full tangent that we do nothing with, but this is y is equal to x. So we can kind of put this on its own side to get this equation. And maybe as we change this number, we get kind of its own metric. Well, let's just kind of try it on the side and see what we get. So I'm going to take y minus x, which looks like that. So I guess it's not too diagonal, but we'll worry about that later. And I want to, again, take an absolute value. So you can see now we're kind of doing this diagonal idea. And I guess if I rotate it, now we're getting something like that more so. So this might not be any better, but we have something like that. And this equation is y is equal to negative x, which when we kind of rewrite it will kind of look like this. I don't know. Is this stupid? Not sure. So instead, we are going to add these together to get our second equation. So y and... Did I use the same number twice? Okay, let me redo this. So this is x. This is y. And I want to quantize this, or sorry, I want to make this symmetric such that now when we add these, I just can't tell. Is this any different? It's a little hard to tell, isn't it? But I'm going to throw it through the same kind of steps. Whereas before we had something like this, and now we have something like that. I think that is what we want, actually. So as I rotate this, do we lose it? Do we lose our math? I don't know. There we go, boys. I think we did it. Great. Okay. So now, in some sense, all I need to do is we added 12 by 12. Let's do it 13 by 13. We might change that later. I want it exactly there. The beauty of doing it live, boys. And again, we can change our kind of factor. I'm like thinking, like, was there an easier way to do this? There might have been, but remember we have our sine wave that we can control, and I guess I'd need to look at the game, but I think it's like something like that. I'm not quite sure. And then we are going to run this through a mix RGB to kind of get this wood color. And, okay, we can play with this a bit later, but now you can see we're getting something pretty good. And the reason this kind of looks weird is we kind of have this pixelization layer which this doesn't have. It's just kind of clean. So what I can do is I can reuse this piece from before, this randomness. Let me kind of get rid of all this nonsense. I can use this piece from before to kind of include both of these. So here's what I'm thinking. We're going to take this, and we are going to multiply by our factor. Okay, so it's going to kind of darken it a little when we set this to multiply and we set this to black. Hold up, somebody's calling me. Is it important? It's Walgreens. They can wait. We're doing a tutorial. Okay, so I want to kind of mix these together. I seem to not understand the math of this for some reason. So let me do something I'm more comfortable with, which is vector math. So if I add this, we're going to get something like this. If I scale it, now this is essentially the brightness. If I now scale it by the white noise texture, there we go. However, you're seeing now we're getting the issue where before we were using 12 pixels, and now we are using 13. So do I want to kind of line these up maybe? I think I do. So let's see if we can kind of cheat this a little. I'm not quite sure how we are going to do it. Okay, so that's lined up. Yeah, we have this issue. So maybe instead of changing this one, let's change our pixelization layer to also have 13 by 13. No. That's not attached to anything. This to 13. Is that fine? So let's see. We have this. We have this. We have this. And I guess all of this is telling me is that our multiplication by the white noise is a bit too strong. So what I want to do is kind of weaken it, which isn't by multiplying. I think that makes it more intense, but rather by adding. So here's before, and here's after. We're kind of lightening this up. Make sure to clamp so we don't multiply by something bigger than 1. And now we're getting back some of our control. This might be a different color. I'm not sure, but whatever. You can tell we got the general idea. Let me see if I can make it look a bit better. So kind of like a more lighter, saturated yellow. And could this be darker or lighter? I'm not really sure what we want. Maybe the reason this looks weird is our like sign thing. So what if we play with the thing? I don't really know. You know what? Sometimes we just got to call it quits. Either way, you can see that this is quite good. And now that we have our color, let's throw it through our BSDF. That's kind of been our final step here, such that that has lighting, and the wood is also to have lighting. Just like this. There we go. So apparently I've kind of left a lot of redundancy here, where I think originally this came from the dirt material. Either way, that's it. Also, now that I'm looking at this, I'm thinking let's add a bit of detail. I don't think Minecraft has this, but can we get some normal mapping? So we have this. I'm going to send it through a height, and now we have, I don't know, that kind of looks weird, right? Let's try it. So I'm going to connect this to a normal map. So this is before and after. Really what it does is it seems to just raise it a little. I think what I actually want is like displacement. But that's not bad, right? That does add detail. Do I want it? I don't know. I think I do. Like, I guess what I'd want, what I'd want is actual displacement or to soften this pixelization so that there's a bit more of a ramp. And I do know how to do that. Let me show you what I'm thinking. I'm going to duplicate this. And all I want to do is I kind of want to soften our quantization. In other words, I want to very, very slightly distort it. And we do know how to do that, right? When we did our grass situation, what we do is we make a noise texture using the same coordinate system. And what we do is we mix these together, but it's going to look a little wonky. It's going to look a little wonky. But I mix these together using linear light. And now you can see we're kind of getting a slightly distorted coordinate system, but I only want to use this for the height. In fact, I don't need any of that. I only want to use it for the height, such that now we should have a bit more to go off of, right? So this is before. It's very perfect. And then after, we're getting just a bit to go off of. And I believe if I was to kind of bring up our noise, is this what I want? I'm not sure, to be honest with you. Do I want to connect this here? I think the issue is we're kind of like straight up using quantization. But whatever. Let's see what this looks like. It should give it a bit of grain in some sense. But that looks kind of stupid, doesn't it? I might need to abandon this idea. Like, just something so subtle, you know? Like, that's what I'm thinking. But it kind of breaks. It does. It kind of breaks our thing. So you know what? We are going to forego the normal map. I'm sorry. But we can kind of change the roughness. So, for example, wood shouldn't be super reflective. It should be fairly rough. And in fact, let me kind of go back and change some of these. So our dirt should be pretty rough. I'm going to set it to 0.75. Everything has a bit of reflectivity. And for our grass, I can also kind of do this. We can change these numbers later. Okay. So at the end of the day, all I've done in this tutorial is make a wood block. But that in itself was kind of difficult. Because again, we're doing it procedurally. If you were to use textures, you know. But that's not what we're doing. So that is our wood block. And now the idea is we kind of stack these together. But do I want these to be the same? I might. Or we could kind of do the same thing from before where we did a bit of randomization, right? So for example, if I take my wave texture and I kind of, what do I want to do? Are we not even using this? Seems like we're not even using this. If I take my wood and I slightly change the number, it's going to give us a different pattern. But really, I guess phase offset is really the way to go. So what this is doing mathematically is it's just kind of shifting things. Oh, I'm sorry about the nose. I think I might have allergies. But what I'm saying is just like before where we had object info. Is that what we did? No, we used... No, we did. We had object info. I include this randomization. And now... Yeah, now it's giving different blocks of wood. So really the question is... You know, kind of the ironic thing here is I spent all this time... Is this even changing it at all? Let me try increasing the phase offset. Maybe it's too subtle. Yeah, that should be a bit better. The ironic thing is I spent so much time doing this, but kind of doesn't matter because we're not going to see it. But either way, I don't know. Maybe only a tiny offset so it doesn't look crazy. Yeah, that looks good. But... when we actually have the game and we remove blocks, it's going to have that nice kind of thing going on. Okay, so luckily for us, the grass block is substantially easier. So what I think I'm going to do is we could do this procedurally, but I think I'm just going to model the tree for simplicity and then kind of duplicate them around. So for now, let's kind of close that and get to our grass block. So again, we have a cube. It should be 2 by 2. Yeah. 2 by 2. Let's get rid of our... What is that? That's bloom. Either way, I just want to make a... I think I keep saying grass. I want to make a leaves block. Obviously, the thing that's different about this is it's green, of course. But we also have transparency. So we almost want to use the same kind of like white noise. but use that to delete certain chunks of it. That's actually quite easy. I can reuse this dirt block thing. So I'm going to take this white noise that's quantized, and I'm going to go to our leaves. Did I not name this? Yeah, so this is going to be leaves. And I want to use this white noise. So initially it's going to look like this, but I want to say either delete it or don't. I don't want to have like half transparent things, I don't think. I don't remember from the game. But if I make this like greater than, less than like 0.5, you can see we're getting something like that. And then this is going to be used as an alpha. Okay, by the way, I mean, I said use 4.0, so if your like sockets look different, that's why. Okay, so that's our transparency. Of course, you can see it's not showing up. That's more so of an Eevee issue. You want to set your blend mode to one of these. Alpha Clip seems to do the job. Some of these are better than others. So you can see some of them do something kind of weird. I think I want Alpha Clip. We can change it later. And we want to take this, kind of make it a dark green, but just like all of Minecraft, I want to kind of randomize the color. So I'm going to use our white noise. In fact, I want to use... No, that's fine. I'm going to use the white noise, and I'm going to mix this basically between two colors. So at this point, the process should be pretty familiar. And that's going to be kind of a light green and also a dark green. And let's see what that looks like when we plug in the base color. So before, after, I think it gives it a bit of something. We can always change it later. So now I'm going to straight up model the thing. But if we kind of proceduralize it, the benefit is that, of course, every tree won't look exactly the same. No, we do have randomness. Okay, so let me try to model this. By the way, so I don't like always have to make this a multiple of 2 when moving it, right? I believe we can just use snapping. But I want to snap it to a different increment. So snap to increment, but how do I decide what the increment is? I don't remember how to do that. Can I do it to vertex? Doesn't like that. I feel like I can do all this complicated GeoNode stuff, but when it comes to... Oh, no, that does work. When it comes to simple things like snapping, I do not know what I'm doing. So I'm just trying to find a good snapping method. I do think increment is the way to go. I just don't know how to change the increment. Is that the same thing as our grid? Let me make this 3. No, that does seem to help, actually. So let's see. If I set this to 1, yeah, now it's more fine. Okay. So I believe I just want to set it to... I don't really know what the correct number is. Let's try 4. It should be a multiple of 2 in my head. Okay, that's close. Let's make it 8. That's kind of nice, actually. Oh, now it's not working. How does this work? Somebody tell me. Okay, whatever. This seems to be fine. This is what I'm going to do. And really, we should be using instances instead of objects. Is that the case? I don't know. For now, I'm just going to make up straight up duplicates. So I'm going to do something like this, and I'm going to speed it up in a second, the workflow. But I want it to kind of look messy. Not the soccer player. And then, to kind of get some free detail, I can take these and kind of reuse them. And then I'm going to delete some of them. Yeah, you can see that's looking quite nice, actually. So I think I'm going to start off by making it symmetric. Oh, that seems to work whenever we're in the 3D viewport. Okay, That is a fact. Uh, so there we go. Just kind of modeling a basic tree. Again, I'd probably benefit from playing the game again to kind of remember this stuff. But maybe it kind of goes lower here and lower here. Like the leaves ought to have different heights. Let's get rid of some of these so they don't look perfect. This one can go down. If you're a Minecraft aficionado and you're saying this tree looks crazy, I'm sorry. I just don't know. And I know some of them have like apples hanging off of them and something like that. I think we're getting close to calling it quits, or rather just good enough. I'm trying to think, what about this looks weird? Is it that the tree is too tall? Is it that the leaves must go lower? I don't do does Blender have, or sorry, does Minecraft have like floating leaves that aren't connected to anything? Probably not. Is this good enough? Or is this ugly? I'm not sure. I think, I'm just going to kind of delete some blocks and see what we can get away with. No, we definitely want that one. You know what? You can only do so much. Okay, so this is our tree. Of course, you'd want to make variations of this, but I want this, I can't, okay, so I could take all of these objects, right, and just kind of join them together. So it's kind of like a single tree, but you can see kind of ruins a lot of stuff, and I do eventually want to be able to destroy some of these blocks. So I want to keep them separate, but rather I'm going to put them in a collection called tree, such that we can now kind of instance it. Okay, we have our tree. Let's finally implement them. So we want the tree only to spawn on the top. It shouldn't spawn on the second layer, the third layer. Of course, the first layer isn't all the same height, but I think I know what we can get away with. So in geometry nodes, we should have already separated our layers. Remember, we have our top layer, and we have all the other layers. And I suppose, really what I want to do, so I'm just trying to find, so where did we instance the cubes? Okay, so I just want this before we kind of populate them with cubes. And if I was to, first of all, let's do something like this. If I was to instance the entire collection, so I'm going to instance on points, and let's say I instance, for now, let's say a cylinder. We're going to get something like that, so there's a tree on every single one. But the idea is I'm only going to do it for some of these. So I'm going to take a random value, I got to eat, and like delete some of these such that most of them do not have trees, but of course we're going to use a collection. And I guess that's the idea. Okay, let's try that. So instead of an instance, let's see. I'm going to take collection info. This may or may not work. I want to use the tree instance relative. I think, okay, so we do have our tree. I think the issue is the way it treats a collection is as a single instance. So let's first of all separate children. So now we have 35 instances. And let's spawn them. Okay. So I think we do have trees, but I think the reason it looks so weird is because we have so many of them. So I'm going to randomize a Boolean like we did before to say where there should and shouldn't be trees. I think this is working. There we go. So we have our trees. Although I believe the issue is, let me kind of tell. So I'm kind of looking up here, for example. I think they're spawning, it's a little hard to tell, but I think they're spawning in the middle. Let's just join these together. Okay. So that's kind of what I want. One issue I'm seeing is that it's a bit underneath it. That's easy enough. I can transform geometry by 1 unit. Okay. So that's easy. However, I'm also noticing that we have some floating trees. I don't know. I guess we just kind of have to try it, right? So here is our landscape. Blender did not like that. Whatever I just did, it did not like that. I really hope it saved our progress. And I really hope the recording has worked. Let me kind of change tabs for a second. I think Blender was doing some freezing a second ago. Okay, let me try just closing it. I don't know what we changed to make it kind of fail. But I hope so much that it saved our progress. It doesn't even... Oh, it's Microsoft Windows? Are you kidding me? So, to be honest, I don't know what that was about, but I looked at the recording, and I think luckily it did save it. So, let's hope for the best. So, I don't know why it crashed, but here's what we got. We got that. I mean, I assume it's because we have so many instances. For now, actually, let's just kind of reduce what we have here, because it seems like Blender doesn't like it too much. So somewhere I should have a mesh line that, yes, has 64. If I was to kind of cut this in half, it would, you know, have less, but now we should have half as many instances. We'll come back to that. But we have our trees. We have this. And now I just want to kind of combine them together. Now, one issue I'm seeing is that they're way lower. So let's see kind of our workflow. We have our thing. That's what I'm instancing now. Then we instance on points on the mesh line. Then we realize that. We instance blocks. And then we separate by the layer. So I kind of want to do the same thing where I separate by the layer. So I really just want to look at which one is the top, which is this grass attribute. So maybe I use this to instance. So something like that. Something like that. Okay, so I'm going to use this to instance. Hopefully Blender likes that. Okay. Don't know what it's doing there. But we are instancing on points. We like that, but then only for a certain... Okay, I think it's basically applying a tree on every single layer. Okay, that's fine, but I only want to do it for a certain selection. So I'm going to use name attribute, the grass attribute, and maybe just multiply these together. So I'm going to multiply with this. And it is all gone. Is it because I need to realize these? I'm not sure. Okay, let's try to troubleshoot together. So we have this. We've stored our grass attribute. And then we instanced our... Oh... Okay. What is... I'm trying to figure out what the issue here is, because we have our grass working up here using the grass attribute. Am I, like, missing something obvious? So we have our mesh line. We're instancing. And then the top layer should have our grass attribute. Okay, I guess let's debug. So we're viewing this. I'm going to look at the grass attribute, making sure to look at it on an instance level, and that itself... Oh, wait. Is it just a question mark? Okay. I like that because it means that basically our theory works. in some sense. Okay. But okay, there we go. So let me tell you what I'm thinking. We got the mesh line. We got our landscape. I'm instancing it. I'm making a geometry so we have points. But only the top layer has data, grass data. And I instance it there. And I might be missing something because I just kind of Blender just crashed. But I believe if I join these two, we should be fairly close. Okay, so that's pretty much working. But again, it seems to be a block underneath, which is fine because I can just kind of offset it by 2. And now I'm just kind of checking for floating trees and other issues like that. Probably easier to see in rendered view. Okay. So we have too many trees. Remember, this number is going to be our tree count. We do kind of want to randomize it in a certain way where we can't have trees intersect, but I believe early Minecraft did have that happen. Either way, I'm going to make 3 times less trees for now and just kind of hope that the randomness kind of carries us. I'm going to change the seed so it's not reliant on other stuff. So we could kind of do more where we're saying this was an issue before where it spawned down here, which wouldn't be quite realistic to the game. But I think that's fine. I just want to make sure, I just kind of want to make sure that everything is lining up in the sense that this isn't like a block offset. It's going to be a little hard to tell, wouldn't it? But the pixels seem to line up. Okay. Let's not stress about it. So that is our thing. It's not too laggy, but remember, at the end we realized our instances, and that seems to make it faster. So our landscape right now has 1.1 million vertices. Fine. And maybe let's kind of save extra compute by getting rid of this stuff on the bottom. So let's see. We have our thing. Fine. We do this. We do the materials. Okay. So I guess what I'm saying is between this step and this step, I want to get rid of some of the detail. So let's see. I'm going to delete geometry. So we have this. Now we have that. It's going to get rid of everything. But I only want to delete the bottom. And how do we know where the bottom is? Well, let's kind of do something more generic. I'm going to take an attribute statistic. I'm going to look at these points. So we're saying we have points. Look at the data of their height, which is going to be the Z component of position. And really what I want to do is I want to look at the minimum. So really this should only delete the bottom layer. So let's see. Yeah. So we have our points, and it seems like we deleted everything because we're just deleting by number, which is not what we want. We want to see where this is equal to the Z component. So only if the Z component is equal to the minimum. Okay, let's check. We have this, we have that. Okay, so it seems to have gotten rid of the bottom layer. However, I wanted to get rid of a few layers until it's... And we could kind of do our math and kind of ensure this, but really what we can do is we can kind of just offset this with an addition. So it's a little hard to see, but that's because I want to delete things that are less than. So not just on the layer, but everything beneath it. Is that right? Is it the opposite? Let's flip these. Yeah, so now we're kind of culling these. So there is a way to do this exactly. In fact, it should be a multiple of 2, I believe. And this number is basically dependent on one of these integers here. But for now, we're going to be lazy. I'm just going to kind of say 6 should be enough. Let's see what that looks like at the very end. So we're kind of getting rid of stuff. Great. Let's bump it up one more layer. Let's bump it up one more layer. And there we go. Actually, this is great because we're getting rid of some extra detail, which will compute not substantially faster, but a bit faster. In fact, what I can do for now, again, is I'm going to reduce the number of layers. I should really kind of label this, but let's say it has a depth of 16, and you can see it's still working because we're computing a minimum. Okay, so we don't need to change any numbers. Okay. You could argue that we want to get rid of one more layer. How many layers do we want to get rid of? Huh. Makes you think, doesn't it? Okay, I think that's a clean bottom. Okay, so now we cut down our instances by a third because we got rid of so much. Okay, let's just play the game and see what we got. So I'm going to go to the layout. What changed? Okay, it's very big is what changed. I'm going to make sure we see all. And really the interesting thing about this is it should be such that every cube is its own object because we realize them at the very end. Not sure if that's accurate, but yeah. Okay, one more thing before we play it. Every tree is oriented the exact same way. I just want to randomize that, and I can't just, so here's where we instance our trees. I can't just use a random rotation where it's only on the z-axis, because you see it will do some things by half rotations. I got to make sure that it's a multiple of 90 degrees. So let's actually do this manually. So I'm going to combine x, y, z. I'm going to make a random value. Again, I'm just going to bump up the seed so it's kind of separate from other random numbers. And I'm going to do an integer where we either want to not rotate it by 90, 180, or 270. So 0 to 3. Then I multiply this by 90 degrees. It might be in radians, but we'll see. And connect this to the z. It is in radians. But luckily we got a node for that. 2 degrees. Huh. Doesn't like that too much. To radians? I'd need to think about that one, but seems to work. We like that. Okay. And you could get weird where you scale it, but again, it would then not respect our thing. Okay. Now, let's try to play it and see what we got. So, I'm going to go into my camera. Reason being is because our camera is going to have additional effects. I'm just going to zoom out. So we have our field of view different. And we've kind of done some extra stuff with our lens distortion and stuff like that. Although that makes it not really like the sky for some reason. We need to think about that. Wonder why that is. I don't think it was doing that before. Bloom? Oh, wait. It's because our background isn't even there. There we go. So I did find, by the way, that ambient occlusion works if you change some number. I couldn't tell you what. But I don't think we're going to get in viewport motion blur, sadly. But that's what the Blender game engine's for. Okay. Let's try to play our game, and hopefully it won't crash the recording. I mean, ideally it wouldn't, because we're trying to make a playable game in Blender. Okay, so now we got trees. Our jump height is not really tall enough. There we go. We got trees, and we can navigate our landscape, where we can fall down. It seems like we can't jump out of this. I'm going to increase our jump height even more so we can get up here. And again, bit glitchy, but that's because we need collisions and stuff like that. But there you go. We got trees. Kind of the next order of business, I think, is to actually break blocks, which you think would be hard, but I don't think it is, because I think we're just kind of deleting instances at the end of the day based on a selection of what the camera is looking at. But there you go. That is Minecraft. Again, you love this? Send the love through Patreon. I'm going to upload this updated version if you want to kind of work on it. For $5, You get this Blender file and everything I've ever uploaded on Patreon. You just get it. So if that interests you, I'm really trying to promote my Patreon recently because I feel like that's kind of the business model that makes the most sense for this channel, because I think, you know, you get cool Blender files and some extra tutorials I made a few months ago. But there you go. Hopefully all of that recorded. We have trees now. They look semi-random. Of course, it would be nice if we made multiple trees to choose from, but that's kind of a later thing. Okay. The recording is still salvaged. So I believe this one was, well, I believe this one was even longer than the previous one. Make sure, not necessarily to like and comment because I disabled those, but if you like it, please join the Patreon. There will be a link in the description to where you can download the file. Thanks for the sponsor, Squarespace, and good shit.